Today I'm going to discuss about the topic folded dipole and Yagi Uda antenna. Right. Now this is the fourth video in the continuous in the second unit which we were seeing from the last three videos. And this is the fourth video where we are saying about the folded dipole antenna. Fine. So the folded dipole antenna. So here just previous videos we have seen that the dipole antenna, whatever we have, dipole antenna, it is of the length lambda by 2, right? In the folded dipole antenna, we are going to have a lambda by 2, that is, we can see in this particular slide where we are having one line, that is, this is the dipole antenna we have, and this is the half dipole antenna, and we are going to fold this, right? We are going to fold this and we are going to have other half. So we have this as a folded dipole. So we have two dipole antennas, right? And we have the two, and it is being connected with the fold. Okay. Now, so we can call that. And another point here to notice that we will be giving the feed at the center. Now, the place where one dipole, right? One dipole will be continuous. One dipole will be continuous, and another dipole will be like a split, right? And then the place where we have a split, there we will be giving the feed to the dipole antenna, right? So it is like the split dipole is fed at the center by a balanced transmission line. So we are just going to feed a transmission line. So in this image we can see a black color wire. This is your transmission line which we are going to use as a feed to this particular folded dipole antenna. Okay, and the two dipoles have the same voltages at their ends, and two identical currents are generated. So this is the structure of the folded dipole antenna. Now we go with the advantages of folded dipole antenna. If we can see the advantages of folded folded dipole antenna, this folded dipole antenna has high input impedance. So it has very high input impedance, hence it makes it easy to match with the transmission line. So the impedance matching will be perfect in terms of the folded dipole antenna. This is the first advantage. Coming to the second advantage of folded dipole antenna, it has a wide band frequency. So it has very wide band frequency, so that is the wide bandwidth, hence it is suitable for FM broadcast and TV broadcast. Okay, that's the second advantage of folded dipole antenna. The third advantage is it has high gain and high directivity compared with the simple dipole antenna. Now, since we are combining two antennas here, so we are having very high directivity compared with the dipole antenna. Hence, it can be used in Yagi Uda antenna. So, these are the advantages of folded dipole antenna. Now, the next step, we are going to calculate the impedance of the dipole antenna. Now, this is very simple. Now, here we have a general formula to calculate the impedance of a folded dipole antenna. So the impedance Z is equal to N square into 73. Now what is 73 here is? 73 is the radiation resistance of a single dipole antenna. So we are going to take now how many number of dipoles we are going to have here. You can see where N is the number of half wave antenna wires, whatever we are going to take. Right now here in an two wire folded dipole antenna. So we are having two wires and it has been folded like two dipole antennas here. In this we are having the value of n equal to 2. So the input impedance of this dipole antenna is 2 square into 73. So it is the impedance we get like 292 ohms. Right? It's very simple calculation. And similarly, for the three wire folded dipole antenna. So for the three wire folded dipole antenna, you can see here the value of n is 3. Therefore, 3 square is 9. 9 times of 73 is 657 ohms. So the input impedance of the three wire folded antenna or folded tripole we call it is 657 ohms, right? The next, that's about your folded dipole antenna. Next we go with Yagi Uda antenna. So Yagi Uda antenna here, the name Yagi Uda has been derived from the two names of the scientists. Now they are from Japan. So the professor is Shintaro Uda initially explained the theory of this antenna in Japanese language in the year 1928, right? And then later it was explained in English by Hidesugu Yagi, uh, right? And it was that means here these two scientists have explained, and in the year 1928, and it was in the personal and commercial use from 1930, right? So this is the oldest type of antenna which we use, right? Now, now we see the construction of Yagi Uda antenna. The construction of Yagi Uda antenna. So towards my left hand side, towards your left hand side, you can see the various parts of the Yagi Uda antenna, and towards your right hand side, you can see an practical implemented antenna. Now we just go with the left hand sided figure. You can see we are having a reflector first coming from the left hand to the right hand. So we are having a clamp, right? A clamp here to support all the elements which are there. Like the first one as reflector. So this is an metallic rod, right? It's a metallic rod. All are metallic rods here, right? Uh, Now, this is a metallic rod uh, which is acting like a reflector, right? This is a reflector. So then next, after reflector, we are having the folded dipole antenna. We can see here we have a folded dipole antenna with a clamp. So clamp is attached here, right? So folded dipole antenna. So to the folded dipole antenna, it is center fed, right? So we give a, so from the center we take two wires and we connect to the transmission line. So it is a center fed folded dipole antenna. The next, we are having an insulator where it is connected to a stand, right, to support the antenna. The next elements are directors. So after your driven elements, we can have as many directors according to our requirement. Now in this figure, this the figure towards my left hand side, I have two directors here. So director 1 and director 2. Now as now we can see the length of the director of the first one. The first director is it is lengthier than the second one. Okay. So this is the construction. So here basically Yagi Uda antenna has three elements called as reflector, then driven element and director. So three elements we have. Now towards the right hand side figure we can see the practical implementation of it. So we can see there is a reflector and side to it you have a director, and then you have a driven element where you have the feed, right? And then actually you have like a folded dipole antenna here, right? And you have a driven feed to it, and then you have multiple directors here. In the left-handed side figure, you have only two directors, but here we have multiple directors, right? Now, now we will see the design of Yagi Uda antenna. So in the design of Yagi Uda antenna, we have to design the length of the reflector, the length of the driven element, and the length of the director. Now these are the set of formulas being used for the design of antennas. Now these are the fixed formulas which are being used for a particular frequency, right? So for a particular operating frequency, the length of the driven element is 475 by uh, that is the operating frequency in terms of feet. So we get, okay. So if we can see the length of the driven element, it will be like, so if you can see towards the right hand side at the uppermost. So we have a driven element here that is as 0.475 lambda, right? In terms of feet we get, right? and then length of the reflector, it is 500 by the operating frequency. So it is like now this is the zero point 0.5 into lambda we have. So we have a reflector. Okay. The next, so this is the reflector, right? And then this is your driven element which we have seen, and then we have the director. Director, it is just like 0.455 lambda, right? Right, it should be like 0.45 lambda, right? And now actually here it has been taken point, that is 455 by f megahertz, so it is very much near. Now this equation, right, this equation, you can see this can be like 0.45, now this can be like 45 lambda, right? And even more than that, now if it is 5 lambda, both the length of the reflector and the director will be same. So in order to avoid, so this value will be like 0.455 lambda, right? And this is the design of the uh, Yagi Uda antenna. Now another point here is the spacing between the antennas. How the spacing should be. So the spacing between the director and the, that is, director and the driven element, if you can see, the distance should be 0.15 lambda, right? So, and then the distance from the reflector to the driven element, it should be 0.23 lambda, right? So this, now we can see here the spacing between the directors, it should be from 0.1 lambda to 0.3 lambda. We just, right? So here the initial conditions has been taken, whatever, right? Initial conditions, and here it has been taken like from the spacing between the driven element to the director, it has been taken the maximum 0.15 lambda. So according to our desired structure, we can use, and we can use within the distances of the specified length. Okay, so this is the design of Yagi Uda antenna, right? Now we can see the radiation pattern of Yagi Uda antenna. So the radiation antenna of Yagi Uda antenna without any reflector. We have a driven element and a director, right? We don't have, consider we don't have any director. Then what happened here? Now, now we have the blue waves and the, now we have the three color waves here: blue, red, and green, right? Now, now these are the waves which are combined. That is, blue is for electrical field and the red is for the magnetic field, right? The E waves, E wave and H wave, which are perpendicular to each other actually. And if they are in phase, if they, that is, the electrical field and the magnetic field, if they are in phase, now the green color is the resultant of it, right? Now, if they are in phase, what happens? We are having a bigger amplitude. Now, the bigger amplitude, and so that means towards the right hand side, it has a bigger amplitude, and thereby we can see the major lobe. It has a very high major lobe, and it has very high directivity. And towards the left hand side, we can see now it has the cancellation of, um, it has a cancellation, that is the E field and the H field get cancelled, and the resultant, the green color waveform, is having very lesser length, so the back lobe it has, and with some directivity, right? So this is the radiation pattern of Yagi Uda antenna without any reflector. Now if we add any reflector, what happens? So if we add reflector, what happens is the side lobe, that is the back lobe, get decreased, right? And however the directivity increases. Now this is the resultant of adding a reflector to this uh, Yagi Uda antenna, right? That's about the Yagi Uda and its construction. We have seen design of Yagi Uda, we have seen, and now coming to the advantages of Yagi Uda antenna. In now Yagi Uda antenna offers very high gain, so we can see due to the director and reflector, right? It has very high gain, right? It possesses a high directional characteristics because of the use of directors. So as we discussed, as we have the number of directors, so the gain, that is the gain also gets increases. Okay. The third point is that it is the low cost antenna, right? And then the fourth point is Yagi Uda antenna shows suitability towards high frequency operations. So it will be working very good with VHF, very high frequencies, right? And it is lightweight and feeding mechanism is also simple. So if you can see that metallic rods which we use for construction of Yagi Uda antenna, it will be of lightweight and it will be easy to operate. Right? Easy and the feeding mechanism is also very simple. It is very power efficient, right? And then the last advantage we can see. Uh, it offers easy of construction and handling, so we can easily construct it and we can easily handle the Yagyuda antenna. So it has an disadvantage. Yagyuda antenna are highly affected by the atmospheric conditions. So due to the strong winds and due to the rain, it will be easily disturbed. Right? Its performance gets affected. So noise is a major factor that disturbs the overall performance of the antenna. Right? So this is the disadvantage. These are the two disadvantages of Yagi antenna. Hope you enjoyed this video. And thank you for listening to this video. Thank you.